Hello there, I'm Mr. Math Guy, and welcome to this 10-minute video on radicals and exponents review. Let's take a look at this first example. We have the square root of 121 a squared b to the fourth, and we're going to simplify this. We're going to assume that the variables represent positive real numbers, and we're not going to do like the square root of 121 is actually plus or minus 11. We're just going to stay with the positive real numbers. So the square root of 121 is 11. Now what we do here, we have to think this is there's an unwritten 2 there. So we think with this variable a squared, and it's a square root, so you just take the exponent and divide it by the index. So 2 divided by 2 is 1, so it's a to the first. 1a comes out of the radical. And then with the b, 4 divided by 2 is 2, so 2 b's come out, or b squared, and you have no remainder, so the answer is just 11ab squared. If we take a look at another example, similar to the one we just now did, we have the square root of 27a to the fifth b. Now we don't know what the square root of 27 is, but what we want to do is try to put these the number into its prime factorization. So back in middle school probably you did something like this, factor tree, and you'd say, well, 3 times 9 is 27, and then 3 times 3 is 9. So 27 is really 3 cubed. So we could kind of rewrite this, if we wanted to, as 3 cubed a to the fifth b. Now the reason that we do that is because now this exponent is larger than an index. So 3 divided by 2 is 1 with 1 left under, right? And then 5 divided by 2 is 2 with 1 left under the radical. And then there's this b, it's just to the first power. And so the exponent is not larger than the index, so none of them can be pulled out, so it's just the b remains under the radical. So it's 3a squared times the square root of 3ab. Let's look at this problem right here, and what we want to do with this one is convert this radical to exponential form. Alright, so this is going to be pretty easy. If we're just going to convert it, we say, well, this is 7 to, remember, radicals are fractional exponents, so it's 7 to the 1 over 2 power, because it's a 1 there, and this is a understood 2, because it's a square root. Now, we got x, and it's going to be to the 1 over 2 power. And then we have y is going to be y 5 over 2 power. So 7 to the 1 half, x to the 1 half, y to the 5 half. This is just converting from radical form to exponential form. This next example, let's do the reverse of what we just now did. This we have x to the 2/5 power, y to the 1/5 power, and this time we have it in exponential form, and I want to convert it to radical form. So I want to put it under a radical. So the first thing you want to do is make sure you have a common denominator, and you do. It's 5. So this is the 5th root of x, and the numerator is your exponent, x squared, and y to the first, or we can just put y. So this is converting from radical form, or from exponential form, to radical form. Sometimes it's very helpful to be able to switch in between these two forms. Alright, this next problem I want to evaluate, 8 to the 1/3 power. Now I know 8 to the 0 power is 1, and 8 to the first power is 8. This is 8 to the 1/3, somewhere in between those two numbers, so this answer should be between 1 and 8. Now, this might be helpful to convert it to radical form. This is the same thing as 8 to the first, the cube root of that. Now, what number times itself 3 times gives you 8? Well, that's just 2. So our answer is just 2. Sorry about that, I kind of showed you the answer. But let's move to this one. What if we have negative 64 to the 1 half? Notice the negative is not in parentheses with the 64. So the answer is just going to be a negative. And if you wanted to convert this to a radical form, it would be 64 to the 1/2 power, or the square root of 64, which is negative 8. Now notice, if this would have been negative 64 in parentheses, it would have been a totally different problem. But it's not, so it's the negative and then whatever 64 to the 1/2 power is. In this next problem, I have 25 to the 3/2 power. So again, it might be helpful to convert this is the square root of 25 cubed. And you'd be like, well, I don't know what 25 times 25 times 25 is without a calculator. Well, then we can take this 25 and we could break it down to its prime factorization. This is really just 5 times 5. So if I wanted to change this, I could rewrite this as the square root of 25, which is 5 squared, and that 5 squared was raised to the third power. Now, when you have a power on a power, you multiply. So this is essentially, come down here a little bit, the square root of 5 to the 6th power. Now, we told you earlier that this index is a 2, and you take the exponent divided by the index. So 6 divided by 2 is 3, so this is 5 to the third power. And 5 to the third power, 5 times 5 times 5, is 125. In a problem like this, where we're to simplify, and we're just going to think of positive real numbers, the rule for adding and subtracting radicals is that the index has to be the same, so they're both square roots, that's good, but the radicand has to be the same. So these are right now not like terms. It's kind of like 7x minus a 3y. All right, you can't combine them. However, we can simplify the square root of 18. It has a perfect square root that goes into it. It's the square root of 9 times the square root of 2. Right? 9 times 2 is 18. Now the square root of 9 is 3. So 7 times 3 is 21, square root of 2 minus 3 square root of 2. Now they're both square roots, and they both radicals are 2. So 21 minus 3 is simply 18, square root of 2. In this next problem, I'm going to be multiplying two radicals. Now, unlike adding and subtracting radicals, you do not have to have a common radicand or a thing under the radical. All right, as long as the index is the same, and they both are square roots. So we can multiply these. We don't have to have them the same. So it's going to be the square root, and 6 times 3 is 18. And a squared times a is a cubed. And b cubed times b is b to the 4th. Rules of exponents, when you add or multiply, you add them. Now, this can be simplified because the square root of 18, as we noticed in the previous problem, is the square root of 9 times the square root of 2, which is 3 square root of 2. So this is 3, and give a little space, square root of 2. Now with the a, this index is larger, or the exponent is larger than the index, so you can divide and pull those out. So 3 divided by 2 is 1, with 1 left under, 1 remainder. And then with the b, 4 divided by 2 is 2, with no remainder. So this simplifies to 3ab squared times the square root of 2a. When dividing radicals, we usually rationalize the denominator, which means we can't have a radical in the denominator. The way that you get rid of it is you say, what's the square root? So 18 to the first times 18 to the first is 18 to the second. And then if it's the square root of 18 to the second, that can be pulled out, and so it's just 18. Or, for example, the square root of 3 times the square root of 3 is the square root of 9, which is just 3. Right? So it just kind of removes the radical. But you got to do the same thing to the top. Now, 18 times 3 is the square root of 54. Now, this is the answer. It just might not be simplified all the way, or reduced, if you want to think of it as that way. So the square root of 54 has a perfect square root that goes into it. The square root of 9 times the square root of 6. And the square root of 9 is simply 3 square root of 6 over 18. Now, you can reduce these numbers right here, so you get the square root of 6 over 6. And you can't reduce these because one's under a radical and one's not. Let's take a look at solving equations with radicals in them. In this particular problem, we have x on both sides, so I want to try to get them together on the same side. And I notice that they're both square roots of x minus 2. So what I could do is I could subtract this one from this side, because they're similar. They're like terms. And I took the 1 to the other side, so I got 4 minus 1. So I have 3 of the square roots of x minus 2 is equal to 9. Dividing both sides by 3, I get square root of x minus 2 equals 3. Squaring both sides, I get 9, and then add 2 to both sides to get 11. Thank you for watching. God bless.